Okay, good morning. Happy Monday morning. As you can see, we're starting a brand new module today, okay? And we're doing module 3. We're starting at the very beginning, which is lesson 1. So module 3, lesson 1. And your learning goal today, by the end of math today, you should be able to make show or model equivalent fractions in 3 different ways. The first way is using a number line. Okay, oops, that's not going to help us. First way is using a number line. The second way is using an area model. What shape is an area model?
Rectangle.
Rectangle. Okay, so to show it, using some sort of a rectangle, which is a square is a type of rectangle. Good. And also with numbers. Okay, so how many different ways are we going to model equivalent fractions? 3. Good. Okay, let's start by talking, since this whole module is about fractions, let's start by talking about fractions. What is a fraction? Talk to your table group. What is a fraction? I heard a lot of people say a fraction is kind of the same thing as a decimal because they both represent a part of a whole. Yes? A fraction is a number that represents a part of a whole. Now, here we have a fraction, 3/4. This is an example of a fraction. The top number is called the numerator. And the bottom number is called the denominator. Okay, go ahead and write that in your notebook. Now, let's start with the denominator. The denominator tells you how many pieces, how many equal-sized pieces your whole has been divided into. So if I have the number 3/4, when I have my fraction 3/4, what number is in the denominator? What number? 4. So that means my whole, let's say my whole is this line. It's been divided into how many equal parts?
3.
How many equal parts? Because my denominator tells me how many equal parts my whole is split into. So if I have the fraction 3/4, how many equal parts is my whole divided into? 4 equal parts. Do you see that? Do you guys see how I divided this number line into 4 equal parts? Okay. The top number, the numerator, tells you how many of those equal parts you have. So if my numerator is 3, how many of my equal parts do I have? 3. So here's 1 equal part, here's 2 equal parts, and here's 3 equal parts. So 3/4 would go from the beginning to right here. Does that make sense? Is this modeling a fraction using a number line, an area model, or numbers? A number line. So do you see how I can model 3/4 by splitting my whole into 4 equal parts and then marking off 3 of those equal parts? Very good. Since our learning goal is talking about equivalent fractions, we need to know what the word equivalent means. The word equivalent means equal or having the same value. So if the directions tell us to make fractions equivalent to 1/2, that means that we are going to be making fractions that have the same value as 1/2. Okay, so there's 3 different ways we're going to do it. As you can see, we're going to do it using a number line, area models, and also with numbers. Let's start with the number line. Go ahead and draw yourself a line like this. And at one end, mark it with 0 and write the 0 at the top. And at the other line end, mark it with 1. That means that the distance between the 0 and the 1 is 1 whole. Yes? Now, if we are going to be making fractions equivalent to 1/2, what's the denominator? 2. That means that this line needs to be divided into how many equal parts? How many equal parts? 2. So go ahead and divide it into 2 equal parts. And let's mark this part 1/2. Okay. That means that the distance between 0, do you guys agree that 0 is 0/2? Go ahead and mark that. Here's 1/2. How many halves do I have all the way over here? 2. So at the bottom, write 2, because I have 2 of those equal parts, and there's 2 equal parts. You can see here's 1 equal part. That's why the numerator is 1. And here, up to here, there's 2. Okay, so that's how you model 1/2 using a number line. Yes? Okay, now, go ahead and draw yourself an area model. Draw a box. Okay? Now, if I split it in half, do you guys see how I have one gray area marked in? Yes? how much of the total box is marked with gray? Half. But if I draw a line going down the middle, now how many sections are there? 4. And how many of them are colored in? Is that still half of the entire box? So is 2/4 equivalent to 1/2? Okay. What if I now split the entire thing like this? How many total sections are there? 6. And how many of the 6 are colored in?
3.
So 3 out of 6. What if I go like this? Now how many total sections are there? 8. And how many are colored in?
4.
So we can see that the bottom number, the denominator, is telling me how many total sections I have, and the top number is telling me how many are colored in. What if I want to divide it into 10 total sections? Would a 10 be in the denominator or the numerator? Denominator, good. And how many are colored in? 5 of those 10 sections are colored in. So all of these fractions, 2/4, 3/6, 4/8, and 5/10 are equivalent to 1/2. Do you see that? Now I'm going to show you how we get there using numbers. Down here, I had 1/2, and I split the top part into 2 sections and also the bottom. So I multiplied both the top, the numerator, and the denominator by the same number, 2, and I got 2/4. Yes? Okay. Over here, originally I had 1/2, and I somehow ended up with 3/6. Do you guys agree that 1/2 and 3/6 are equivalent? They have the same value? Yeah. Okay. How did I get there? How do I go from 1 in the numerator to 3 in the numerator? What do I need to do? I need to multiply 1 by 3. What about the denominator? I went from 2 to 6. How do I get from 2 to 6? I need to multiply the number 2 by 3. So you can see here I made an equivalent fraction using numbers by multiplying both the numerator and the denominator by 3. Do you see that? 3/3. What's the value of 3/3? 1. Can I multiply things by 1? Does it change the value if I multiply something by 1?
Nope.
So over here, am I multiplying 1/2 by 3?
No.
I'm actually multiplying 1/2 by 1. The number 1 is kind of like Ditto. Do you guys know the Pokemon Ditto? It can take on lots of different forms, can't it? Ditto sometimes can look like Pikachu. Sometimes Ditto can look like Diglett. It can look like different Pokemon, can't it? The value of 1 is like Ditto because it can take on lots of different forms. Over here, 1 is taking on what form? Two halves. Over here, 1 is taking on what form? 3/3. What form of 1 am I going to use to get 1/2 to become 4/8? 4/4. Because over here, using numbers, I can show I did 1/2 times the version of 1 that looks like 4/4 to get 4/8. Do you see that? What about over here? How did I get from 1/2 to 5/10? I had to multiply by 5/5. Now we can see that 1/2 is equivalent to 2/4, 3/6, 4/8, and 10/10. So over here on the number line, instead of writing 5/10. Instead of writing 1/2 here, we could also write 2/4. Do you agree?
Yeah.
We could also write what? 3/6. Or what? 4/8, etc. Okay? A very common mistake people make is they say, oh, I need to divide it into 3 parts because my denominator is 3. That means I'm going to draw 3 lines. If I draw 3 lines, how many sections will I have?
4.
So be careful. In order to make 3 sections, we actually only need to draw 2 lines. Do you see that?
Yeah.
Okay, now I've divided it into 3 sections. This first section, how many thirds have I gone so far? 1/3. Over here, how many thirds have I gone? 2/3. And over here, how many have I gone? 3/3. And over here, of course, is 0/3. So how many, if I'm trying to show 2/3, which tick mark is 2/3? This one right here, right? Very good. Now let's use an area model. Let's go ahead and draw an area model, okay? If I'm going to draw 2/3, if I'm going to show 2/3, I need to split it into 3 sections. Again, how many lines did I draw to make it into 2 sections? 3 sections? 2 lines, good. Now how many of those sections do I need to color in?
2.
Because my numerator is 2, so it's showing that I have 1 of those thirds and now 2 of those thirds, yes? So we can show that this is 2/3. Now, actually I'm going to write it down here in the numbers. Okay. 2/3. Now, if I split it, let's say I split this whole thing in half. Now, how many total sections do I have?
6.
6, and how many of are colored in?
4.
So that means 2/3 is equivalent to 4/6. How can I use numbers to get from 2/3 to 4/6? What do I need to do? Martin?
The numerator and denominator by 2.
If I multiply the numerator and the denominator by 2, what number am I multiplying my whole fraction by? 1. But do you see how I can use numbers to do it that way? Okay, let's do another one. So I'm going to start again with 2/3. Do you guys agree that this is 2/3? Yes? Now I'm going to split it into 4 like this. How many total sections do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many total sections did I split my area model into?
12.
That means 12. Should that be my numerator or my denominator? Denominator. Good. Okay. How many of those 12 sections are colored in? 1, 2, 3, 4, 5, 6, 7, 8. Does that mean that 2/3 is equivalent to 8/12?
Yeah.
How would I get there? How would I get from 2/3 to 8/12? Multiply by 4. Multiply by 4?
Oh, 4.
If I multiply something by 4, will it keep the same value? No, so I'm not multiplying by 4, but you're on to something. What am I multiplying by? 4/4. Good. Which is